Hello, we're going to start with a little review exercise. I would like you to use what you remember about finding inverses to try to find the inverse functions for both of these. On this first one, we can just switch the x and the y. And now we need to get the y by itself. So this is actually just going back to those equations that we've been solving. We need to get this y by itself. It's up in the exponent. What we do when we're trying to solve for something that's up in the exponent is we use a log. And we think what to the what equals what. And in this case it's e to the y plus 3 equals x over 4. And we almost have the y by itself. We just need to subtract 3 from both sides. By the way, log base e is natural log. And remember, we were going to subtract 3. And that would be our inverse function. The inverse of any sort of e to the x is going to wind up being some sort of natural log. What do you think the inverse of a log base 2 will be? Now this time we're trying to solve for a y that's inside a log. And basically, if we have an exponential, we go to logs. If we have a log, we go to exponential. So we're thinking what to the what equals what? 2 to the x minus 3 equals y plus 1. 2 to the x minus 3 equals y plus 1. Our y is almost by itself. And there's our inverse function. Hopefully you guessed that the inverse of a log base 2 is going to be an exponential 2 to the x. Our lesson today is going to be writing functions that look like y equals a times b to the x, and they're going to give us 2 points on the graph, and that's it. 2 points on an exponential graph. This one looks like it's going to be growth, right? Because it starts out at 1, 8, and then it goes to 2, 32, and seems like it's growing, yeah? Now, one way you could do this is to try to figure out what your base is going to be, what is the multiplier, and what would this initial value be. And some people are really good at just figuring that out. I'm going to show you the algebra way of finding that. So the idea is we have an x and a y. We have another x and a y. And we have kind of this baseline equation. Now our goal is to fill in that initial value and that base number. We need to find out what a and b are. So let's try this. So we know y is 8 when x is 1. We know y over here is 32 when x is 2. And so we have a system of 2 equations and 2 unknowns. The a and the b are the things we need to find out. And I like to do these with substitution. So here's how I like to do these. I like to, let's say, take the first equation and solve for a. If I got the a by itself, I'd divide that b to the 1 over. So 8 divided by b to the 1. And then if I take that and substitute it into the second equation, then I just have b in this equation. I should be able to solve that. Now I've got b squared divided by a single b. b squared divided by b would just be b to the 1. Check it out. We know what b is. Now this isn't our final answer, but that we're definitely going to need that to put in our final answer. So we know b is 4. Now we need to find a. So how about we go back to that 8 equals a times b to the 1. Doesn't matter which equation you pick. Let's go back there. We'll substitute in our newfound b, 4 to the 1, divide both sides by 4, and we've got an a. A is 2. Now your final answer is just going to be this equation with the a and the b plugged right on in. And if you're nervous, you can always go back and plug in a 1, make sure you get an 8. Plug in a 2, make sure you get a 32. I want you to try this one. I like to take the top equation and solve for a. A equals 8 over b squared on this one. Now if we take that and substitute it in, here we've got b to the 4th divided by b squared. If we subtract the powers, divide both sides by 8. Now this is 1/4. Square root of both sides, and we get 1/2. 1/2 times 1/2 would have made 1/4. Technically, it could be plus or minus 1/2. You know, when we do these equations, though, I just want you to worry about the positive one, because we really never talk about exponential equations where the base is a negative number, just because the graph is ishy. So, you know, you could write 2 different equations, one where the b is 1/2, one where the b is negative 1/2. We're just looking for the positive one. We still need to find a. Remember how to do that? You're just going to pick one of your equations. And we know b now. And now we know a. Now our final answer is plugging those two in. A times b to the x. Always a good idea just to check. If I plug in a 2, I should get an 8, right? So I'd have 1/4 times 32 makes 8. I'm pretty convinced. I could check the other one if I was doubting myself. Now there's one other type of problem, and this is a power function. We learned about power functions back in the day. The method for solving these is just a little bit different, and like I said, any way that you can figure out that makes sense to you, to figure out what the a and the b again is fine with me, but I'm going to show you the algebra way. The algebra way again is just to plug in an x and a y. X and a y. So I've got 4 equals a times 3 to the b. So this just looks a little weird since we just did those last problems, but this is the idea. Y equals a times x to the b. Now, I found that the easiest way to solve this type of problem, to figure out my a and my b, it's going to look a little weird at first, but we're going to basically set up this equation divided by this equation. Because if we know that 7 is equal to a times 6 to the b, we should be able to divide both sides by something that's, like, we could divide by 4, or we could divide by 4 and something that's equal to 4. That's my favorite way of solving these. Now I know that doesn't look really sweet, but here's the idea. These a's cancel out, and that's sort of the goal, is to get it so we can, you know, have just one variable. So I've got 7/4 equals, since those are both to the b power, we really could write it like this, couldn't we? 6 divided by 3 is 2. Now, since you'll be doing these on the no calculator part of the test, you'll always be able to figure out what b is from here. Right now, I'm not sure 2 to the what equals 7/4, so I have to use my backup technique. If I can't figure out what the exponent is, I go to logs. So this one's going to translate into log base 2 of 7/4 equals b. And I would be just fine with you approximating that. So let me type that in quick. And I got 0.8074-ish. And we're okay with you just using that decimal approximation from here. Once we have that, next step, we need a. So we'll take one of our equations. Now we know b. Solve for a, we'll just divide both sides by whatever number this is. 4 divided by 3 to the 0.8074. And I'm still saying approximately equals because I remember that was a rounded number anyway. Now I have an a value. Beautiful! Now I just need to plug it back in. We're going to give these equations to you, so you don't need to worry about that. You just need to plug in your a and b when you're done. You're going to see some of these with decimals on your assignment, but like I said, on the test, they're all going to come out super nice so that you can do them without a calculator. Last one, let's give it a shot. I can see getting stuck right at this step if I were you. So, you know, if you can find another way to figure out the a and the b, I would totally welcome that. Remember, my favorite method is to make a ratio of the two. Because that's really what a power model is all about anyway. Since it's all about multiplication, it's all about making ratios. And here again, those a's cancel out. How convenient. Since both of those have the same power, I could call that 8/4 to the b. That's 2. If I'm trying to solve for b and it's up there, we're going to go with a log. Log base 2. Type that baby in and I've got an answer. .3479. Off to find the a. Take one, you know, it doesn't even matter. Pick one of the original equations that you had plugged in for. Get that a by itself. This is the awkward silence where I'm using my calculator. And I get a is about 6.7910. Final answer being a times b to the x. A times, oh, I didn't mean that. a times x to the b, power model. A times x to the b. Now, if you go back and you check your answers on these, remember we did some rounding, so when you plug in a 4 for x, you might not get exactly 11, but it should be darn close. That would be the end of the lesson for today, and I'd like you to work on your homework, please. Thanks.